Hey guys, I thought I'd just kind of share with you sort of like putting it all together for rational exponents just for a few minutes. So let's say we wanted to evaluate 32 to the power of 4/5. Well, one thing to recognize here is what things is 32 a power of? Now 32 is an easier one because the main thing is it's a power of 2. But if we had something like 16, 16 is a power of 2, but it also could be a power of 4. So you may have to kind of make some decisions. Same with like 81. It's a power of 3, but it's also a power of 9. But the real question we want to ask here is, we're looking for something that can be split into fifths. And we're talking geometrically speaking, not arithmetic, right? We're talking multiplication, aka exponents. And so 32, luckily, is the fifth power of 2. Now, some of those lower powers I would expect you to make sure that you know. So if we think of this as 2 to the fifth and then to the 4/5, we can kind of see that our base is 2. So leading into the geometric sequence way of looking at it, what we're saying is our multiplier here is 2, or what we call our constant ratio, right? And so it helps us to actually visualize this by seeing that, okay, every single time here we're multiplying by 2 all the way across. Now at this point we want to realize that 32 is to the power of 1, right? Technically, because if you look, our original base is 32, so kind of the end of our sequence, which obviously could go further, but for now, is going to be 32. And remember, if that's a power of 1 and I want it in fifths, just think of that as 5/5, right? So at this point, essentially, every single time we're going down here, we're going to drop a fifth of a power of 32. So this would end up being 32 to the 4/5, 32 to the 3/5, 32 to the 2/5. This is 32 to the 1/5, and then this is 32 to the 0/5. So that makes sense because that's just 32 to the 0, and we know anything to the power of 0 is always just equal to 1, right? So another way to kind of think of how to split this up in the right way, I guess, would be maybe to start and think, oh, well, this needs to be fifths, and we need to start with 0. So 0/5, 1/5, 2/5, all the way up. And then when you get to 5/5, you have one full entire power of 32, right? So we're looking at like multiplicatively building up to a power of 1, right? So this helps us here because it also helps show, in this case, for example, we've already seen that 32 to the power of 1/5, we realize that's the same as saying the fifth root of 32, which of course is 2. Okay, so that kind of ties those ideas together there as well. And then of course, what are we looking for? 32 to the 4/5. So I'll circle in red the actual answer for what we're evaluating here. And based on how we listed our sequence out, we can see, oh, okay, 32 to the 4/5 is 16. And I've already kind of said it this way, but remember, we're also thinking 16 is 4/5 of the way to 32. So if I built that geometric sequence, it's 1, 2, 3, 4/5 of the way there, okay? So I hope this kind of, I don't know, maybe ties a lot of things together for you a little bit. One last comment to end this is an interesting way to evaluate that I forgot to mention to you guys before, actually. If you can turn 32 into something that's power of 5, you remember the rule that says if I have an exponent with another exponent on it, we multiply, right? So actually, this is a pretty cool way to evaluate these directly. You didn't have to use the sequence, of course. You have multiple ways we could figure out what 32 to the 4/5 is. But if you write it like this, then this becomes 5 times 4/5. And of course, those 5 cancel out. And so that becomes just 2 to the 4th, which is 16. So that's a cool way to put these ideas together, actually, with that as well. Okay, but I do want you to be able to evaluate using this way, like a way like this, maybe turning into roots and understanding how these tie into roots as well, and also understanding geometric sequences, because especially for some stuff later, those are really important. So I just wanted to share that with you guys for today, and see you later.